In this video, you will be introduced to stoichiometry. Stoichiometry is a way that can determine the relative proportions in which substances react in a chemical equation. We have to keep in mind equations must follow the law of conservation of mass, wherein matter is neither created or destroyed in a chemical reaction, and all equations must be balanced. A balanced chemical equation tells us a lot of information about what is happening in that reaction. So if we take the example of nitrogen reacting with hydrogen to produce ammonia, when we have this equation balanced, it tells us that one nitrogen molecule will react with 3 hydrogen molecules to make 2 ammonia molecules. And so this leads to what we call a molecular ratio, which we can use to express the numbers of molecules in an equation. So that means for every 1 molecule of nitrogen, 3 molecules of hydrogen will react to produce 2 molecules of ammonia. If we multiply the ratios by 2, that would mean that 2 molecules of nitrogen would react to give 6 molecules of hydrogen to produce 4 molecules of ammonia. And so we could keep multiplying these ratios and we will always know that it will always react in a 1 to 3 to 2 ratio. So what if we multiply the ratios by Avogadro's number, or by 1 mole? That would mean that we would have 6.02 times 10 to the 23 molecules of nitrogen reacts with 3 times 6.02 times 10 to the 23 molecules of hydrogen to produce 2 times 6.02 times 10 to the 23 molecules of ammonia. Or, in other words, we could say that 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. And so a balanced chemical equation gives us the ratio of moles of reactants and products. This is known as a mole ratio. And so we're going to use mole ratios in a way that will allow us to determine if we know the amount of one substance in moles, we can calculate the amount of another substance using this mole ratio. Let's take a look at an example then. We're going to use the same reaction. N2 plus 3H2 reacts to give 2 NH3. If there are 2.8 moles of hydrogen, how many moles of ammonia will be produced? Now when you're setting up a mole ratio, the way that I like to set them up, and there's a couple different ways, but this way I think makes probably the most sense, is that we're going to set up what we know from our given balanced chemical equation on one side, and then we're going to equal to that to what we're given and what we're trying to find on the other side. So this is going to, this is how it's going to look. The two substances that we're interested in here are hydrogen and ammonia. So if we look at our balanced chemical equation, we know that for every 3 moles of hydrogen that react, we produce 2 moles of ammonia. So in terms of expressing this in a ratio, we're going to write 3 moles of hydrogen over 2 moles of ammonia. So that this side here is from our balanced equation. Okay. On the other side, we're going to take what we're given in the problem. So we know that we've got 2.8 moles of hydrogen, and we want to find out how many moles of ammonia will be produced. So setting up the second side, if you have moles of hydrogen on the top, you got to make sure that you have moles of hydrogen on the top on this side as well. Okay, so our given value is 2.8 moles. So this is our given value. And then we're going to divide it by what we're trying to find. So we don't know what the number of moles of ammonia is. We'll just put in X for that. So this is what we're trying to find. Make sure that whatever you have on the top here matches on the top of the other side. Whatever you've got on the bottom here matches up with the bottom on the other side. You could have set this ratio up with the ammonia on the top and the hydrogen on the bottom. Either way will give you the same answer. And so what we're going to do to find the number of moles of ammonia is we're going to cross multiply and then isolate for x. So we have 3x is 2 times 2.8, and then dividing both sides by 3 gives us an x of 1.9, and that is moles of ammonia produced. Okay. 2 significant digits here because we've got 2 sig digs for our moles of hydrogen, and we're only multiplying and dividing, so our answer should have 2 sig digs as well. Alright, so let's try one more example, and this one's a little bit more complicated. We have the same reaction, but we've got 9.0 grams of ammonia being produced. How many grams of hydrogen reacted? So we know we're given 9.0 grams of ammonia, and we want to find the mass of hydrogen. The way that we want to set this up is our first step, we always want to check to see if we've got a balanced equation, okay, which we are given here, so we don't need to balance that. Now, in order to figure out the grams of hydrogen, we have to be able to compare moles. We can't just compare grams because we know molar masses are different for every compound. So if you're given a value as a mass, you're first going to have to convert that to moles in order to use a mole ratio. So to find the moles of ammonia, we're going to take the mass and divide it by the molar mass. So 9.0 grams, and then the molar mass of ammonia is 17.04 grams per mole. Okay. You're using it for just ammonia. Don't worry about this 2 here because the 2 is taken care of in the next step in the mole ratio. If you calculate this, you get about 0.5281, and it keeps going on, moles of ammonia. Okay, we don't want to round off here yet because we're not finished answering the question. Now that we know the number of moles of ammonia, we can use a mole ratio to find out the number of moles of hydrogen that would need to react with it. So to set this up, this is our third step, we're going to take our mole ratio from our balanced chemical equation. So we know 3 moles of hydrogen react to produce 2 moles of ammonia. And this time we don't know how many moles of hydrogen we have, so we're going to use x for that. And we calculated that we've got 0.5281 moles of ammonia. Okay. So solving for this then, we'd have 2x is 3 times 0.5281, or x is equal to 0.7922, number goes on again, moles of hydrogen. Okay. Again, still not rounding off here because we're not done our question yet. Finally, we want to find the mass of the hydrogen that reacted. So in order to do that, we need to convert from moles of hydrogen to mass. So our mass of our hydrogen is going to be the number of moles times the molar mass of hydrogen. So we've got 0.7922 moles of hydrogen, and the molar mass of hydrogen, 2 hydrogens, gives you 2.02 grams per mole, which would give you a mass of, and if we round off to significant digits, we need 2 here, so 1.6 grams of hydrogen is produced. Just to recap then, there are 4 main steps that you should follow in any stoichiometry question. The first is you should write a balanced chemical equation if one isn't given to you, or it's not balanced. 2, you should convert the given value in the question to moles if this is required. Next, you should use a mole ratio to determine the unknown mole value. And finally, you should convert the unknown value from moles to the units required by the question. If you follow these 4 steps when solving any stoichiometry problem, even if you make a mistake somewhere, you will always get at least part marks for showing me this work.